Imagine a world where Earth was nothing but a dry, lifeless rock. No oceans, no blue skies, no verdant landscapes teeming with life. 4.5 billion years ago, that was our planet's reality, a barren sphere orbiting a young, violent sun. It was a world utterly hostile to everything we consider essential for existence. No gentle tides, no life-giving rain, just a desolate, primordial expanse. This early Earth, born from the accretion of cosmic dust and gas, was a very different place from the vibrant home we know today. It was a planet adrift in the cosmic dark, waiting for a catalyst, a transformative event that would set the stage for everything that followed. Then, an unseen force, a celestial dance partner, emerged from the chaos of the early solar system. Its name, posthumously given, is Theia, a protoplanet roughly the size of Mars. Theia was on a collision course, a gravitational imperative drawing it closer to the nascent Earth with terrifying speed. For millions of years, these two worlds orbited the Sun in a delicate, unstable ballet, until approximately 4.5 billion years ago, their paths converged. The impact was not a glancing blow, but a cataclysmic head-on collision, a cosmic hammer striking an embryonic anvil. The force of this impact beggars belief, releasing more energy than all the nuclear weapons on Earth combined, 1,000-fold. It ripped open the Earth, scattering molten rock and superheated vapor into space, fundamentally reshaping our world in an instant. This wasn't merely a bump, it was an act of planetary creation and destruction, all at once. From the unimaginable violence of this collision, two monumental gifts emerged. Gifts so profound that without them, you and I might not exist. First, the moon. The debris ejected into orbit from the impact coalesced over time, forming our faithful lunar companion. The moon, often taken for granted, is Earth's gravitational anchor, stabilizing our axial tilt, preventing extreme climatic wobbles that would make long-term life impossible. Without it, Earth would precess wildly like a tumbling top, swinging from Arctic cold to scorching heat in relatively short geological timescales. Second, and perhaps even more crucial, the collision delivered vast quantities of water and essential volatile elements to Earth. Theia wasn't just a dry rock, it was a cosmic delivery truck, bringing the very ingredients for oceans and atmospheres, shielding our delicate biomolecules from the sun's harsh radiation. This isn't to say Earth had no water before Theia, but the impact significantly augmented our supply, perhaps even kickstarting the process of plate tectonics, a geological engine critical for recycling carbon and regulating our climate. This isn't just a captivating story, it's a scientific hypothesis supported by a growing body of evidence. Lunar rock samples brought back by Apollo missions, for instance, show a striking isotopic similarity to Earth rocks, hinting at a shared origin. The moon's remarkably large size relative to its host planet and its density are also consistent with a giant impact event. Computer simulations, run on supercomputers for decades, meticulously recreate the collision, demonstrating how such an event could both form the moon and imbue Earth with its unique characteristics. Furthermore, the presence of certain siderophile or iron-loving elements in Earth's mantle, rather than having all sunk to the core, further supports the idea of a massive rehomogenization event caused by Theia's impact. The scientific community has largely converged on this giant impact hypothesis as the most plausible explanation for the moon's formation, and by extension, for many of Earth's life-enabling features. But what if Theia had missed? What if this cosmic ballet had ended not in a catastrophic embrace, but with Theia simply passing by, a silent ghost in the cosmic void? Our world would be drastically different, almost unrecognizable. Without the moon, Earth's axial tilt would be unstable, causing extreme, rapid climate shifts. Imagine seasons so severe that entire continents freeze solid for centuries, only to thaw into tropical deluges. Life, if it could even emerge, would face an impossible struggle for adaptation. Furthermore, without Theia's contribution of volatiles, Earth might have remained a much drier, more arid world, perhaps even without the extensive oceans that cover 70% of our surface. The very atmospheric conditions necessary for complex life might never have formed. The day-night cycle, currently around 24 hours, might be far shorter or far longer, leading to extreme temperature differentials. The Earth, we know, a temperate blue marble teeming with biodiversity, would simply not exist. It's a sobering thought, highlighting the incredible luck inherent in our planet's violent past. Let's delve deeper into an Earth without a moon. The tides, those rhythmic pulses of the ocean driven by lunar gravity, would be negligible, perhaps only caused by the sun. This would drastically alter coastal ecosystems, which rely on the intertidal zone. Imagine no mudflats, no tide pools, no rich biodiversity cradled by the ebb and flow. But the greatest impact would be on our planet's stability. Our axial tilt of approximately 23.5 degrees is what gives us stable seasons. Without the moon's gravitational tug acting as a cosmic gyroscope, Earth's tilt would wobble chaotically, potentially swinging from 0 degrees, no seasons, to 80 or even 90 degrees, extreme seasons where the poles face the sun directly for half the year. Such colossal climatic variations would make the sustained evolution of complex life forms incredibly challenging, if not impossible. The very concept of stable climate zones would be a fleeting illusion. It truly puts into perspective the moon's silent, unseen role as the ultimate guarantor of Earth's biological continuity. Now consider the prospect of a much drier Earth. If Theia didn't deliver its payload of water and other volatiles, our planet might be more akin to Mars, a desolate rocky expanse with minimal surface water, locked away perhaps in polar ice caps or deep underground. Our vast, life-giving oceans would be absent, replaced by vast, dusty plains and canyon systems carved by long-dead rivers. The carbon cycle, crucial for regulating Earth's temperature, relies heavily on water, dissolving atmospheric CO2, forming carbonates, and facilitating plate tectonics which recycles these compounds. Without ample water, this intricate planetary thermostat would malfunction. The atmosphere might be thinner, more prone to escape into space, or choked with greenhouse gases without the oceanic carbon sinks. The very bedrock of our existence, liquid water, would be a precious rarity, fundamentally altering the course of abiogenesis, the emergence of life from non-living matter. Life as we understand it requires a solvent, a medium for chemical reactions, and water is the ultimate solvent. A dry Earth would be a silent Earth, devoid of the symphony of biology. The absence of Theia's impact could also have profoundly altered Earth's early atmosphere. Without the volatile rich material from Theia, and potentially without the enhanced volcanic outgassing driven by plate tectonics, our atmosphere might have remained thin, perhaps composed primarily of inert gases or lacking the crucial elements that would eventually lead to an oxygen-rich environment. Early Earth's atmosphere was very different from today's, a reducing atmosphere dominated by methane, ammonia, water vapor, and carbon dioxide. The processes that led to the Great Oxidation Event, where cyanobacteria began pumping oxygen into the atmosphere, relied on a stable environment and abundant water. Without these prerequisites, oxygen might never have accumulated to significant levels. Imagine a planet without a protective ozone layer, constantly bombarded by harmful UV radiation, making land-based life virtually impossible. The very air we breathe, the invisible shield that protects us, owes its existence in part to that ancient, violent collision. It's a cascade of dependencies, all stemming from one cosmic event. And what about plate tectonics? Some theories suggest that Theia's immense impact was not just superficial, but permeated deep into Earth's mantle, initiating or at least significantly enhancing the process of plate tectonics. This geological engine is a cornerstone of Earth's long-term habitability. It recycles crustal material, releases volcanic gases that replenish the atmosphere, creates continents, and drives the magnetic field that shields us from solar winds. Without robust plate tectonics, Earth might have become a stagnant lid planet, like Venus or Mars, where the crust is a single unbroken shell. On such planets, heat from the core cannot efficiently escape, leading to potentially catastrophic periodic resurfacing events, or simply a geologically dead world. Without the constant churning and renewal, the carbon cycle would grind to a halt, leading to runaway greenhouse effects or deep freezes. The dynamic, ever-changing Earth, a crucible for evolution, would be replaced by a static, perhaps lifeless orb. Theia's impact, therefore, might have been the ultimate geological kickstart. From this cosmic perspective, the story of Theia isn't just a scientific curiosity. It's a profound testament to the delicate, often violent, cosmic ballet that orchestrated our very existence. It reminds us that our seemingly stable home is the product of unimaginable chaos and precise celestial mechanics. The Earth we inhabit, with its vibrant ecosystems, its deep blue oceans, and its breathable atmosphere, is not an inevitability but a marvel of cosmic contingency. Every sunrise, every gentle breeze, every drop of rain, every beating heart, all trace their lineage back to that moment, billions of years ago, when two worlds became one, and from their spectacular demise, forged the conditions for life. It's a story of destruction leading to creation, a reminder that sometimes the most catastrophic events are precisely what's needed to ignite something truly extraordinary. Considering all these factors, the unique conditions on Earth, its stable tilt, its vast oceans, its robust atmosphere, its active plate tectonics, all seem to converge back to that single defining event, the collision with Theia. This doesn't just make Earth rare, it makes it a cosmic lottery winner, a planet whose violent past perfectly paved the way for complex, intelligent life. When we gaze at the moon, we aren't just looking at a barren rock, we are looking at the remnants of another world, a piece of our own violent origins and a silent guardian of our present. It's a constant reminder that the universe is a place of unfathomable power and incredible serendipity. The very existence of life on Earth, of you and me, is a direct consequence of a cosmic accident, a fortunate catastrophe. So, the next time you look up at the night sky and see the moon, remember Theia. Remember the planet that made life possible, not by gentle creation, but by an act of cosmic violence that redefined our world. It's a story that challenges our perception of destiny, proving that sometimes destruction is the ultimate forge of life. What other cosmic accidents, big and small, have shaped the universe around us? The possibilities are endless, and the more we learn, the more we appreciate the improbable miracle of our existence. If this journey through deep time and planetary formation intrigued you, make sure to hit that like button, subscribe for more cosmic explorations, and share your thoughts in the comments below. What other what-if scenarios would you like us to explore? Until next time, keep looking up.